Now for an AND type inequality, there are four possible pictures. There are four possible ways that things could work out when we go to simplify our solution. The first type has as an example x is greater than -4 and x is less than or equal to 7. When we draw the two pictures, we'll mark -4 and we'll mark 7. X is greater than -4, that goes off to the right and gets a round bracket. X is less than or equal to 7, that goes off to the left and gets a square bracket. Where do they overlap? They overlap in between. -4 gets a round bracket, 7 gets a square bracket. We can't simplify at all. We need both inequalities. In interval notation, our interval has numbers at both ends. When does this happen? The graphs point in opposite directions and they overlap. And the place where they overlap then is our interval. So that's type 1. The second type has, as an example, x is less than 14 and x is less than or equal to 2/3. So again, here's 2/3, here's 14. X is less than 14, we start at 14 and go to the left. X is less than 2/3, we start at 2/3 and go to the left. Where do they overlap? Well, they overlap in this part over here. And the actual point 2/3, well, it's on this ray and it's on this ray. So that's part of the overlap too. Right, the same bracket as the point that you're copying. Right, so here, looking at this new graph that we drew, this graph looks just like the graph of x is less than or equal to 2/3. And of course, anything that's smaller than 2/3, it's also going to be smaller than 13. So our solution simplifies to just x is less than or equal to 2/3. Saying that x is also less than 14, well, that's redundant. In interval notation, here we have no left end, 2/3 is the right end. I see a square bracket here. I'll write a square bracket here. When does this happen? This happens when both graphs go off to the left. Of course, if both graphs go off to the left, they will overlap. The third type has as an example, x is greater than -5 and x is greater than or equal to -8. Now in drawing these number lines, I'm going to think just for a minute about what order -5 and -8 ought to come in. -8 is further to the left on the number line than -5 is. So what do these graphs look like? Here's x is greater than -5. He gets a round bracket. X is greater than or equal to -8. He gets a square bracket. Where do they overlap? Well, not here. Just over here. Right? And this point -5, well, it's not on this graph, so it's not in the overlap. So this graph looks just like this graph. Our solution, we can just say x is greater than -5. That makes sense. Anything that's bigger than -5 is already, for free, bigger than -8. In interval notation, we start at -5, which gets a round bracket, because I see a round bracket here, and goes up to positive infinity. There's no right end. All right, what's left? What's the last type? The last type has an example. X is less than negative 25 and X is greater than negative 24. Again, I might need to think for a minute about what order these negative numbers come in. 25 is further to the left. X is less than negative 25. That's like this. He gets a round bracket. X is greater than negative 24. He also gets a round bracket. And now I look and I see, what points do these have in common? And I see, well, none of them, right? Nothing over here is also over here. There's this gap in the middle where they don't have anything in common. So here we have no solution. If we want interval notation or set builder notation, we can write this symbol. This symbol is read the empty set. It's the set that doesn't contain anything. So, since there are no solutions, if we sat down to make a list of all the solutions, there would be nothing on the list. So these four pictures, arrows in opposite directions that overlap, arrows that both point to the left, arrows that both point to the right, and arrows that point in opposite directions that don't overlap, right? They correspond to solution sets that look like the empty set, an interval from a number up to positive infinity with an appropriate bracket, an interval from negative infinity up to a number with an appropriate bracket, and an interval from one number to another number with appropriate brackets on both of them.